Since the equation of a circle seems to have nothing to do with inequalities, it's a lot like my cameo in the 2003 Super Smash Hit action blockbuster movie, The Rundown, that I'm going to be explaining this to you and then handing it back to your teacher to explain the rest of inequalities. So, first of all, you might be asking, Arnold, how is it that you are qualified to explain equation of a circle to me? Well, little do you know that I like to spend all my downtime pumping iron and crunching numbers. So let's get to work. The equation of a circle can be reminded to you as x minus h to the power of 2 plus y minus k again to the power of 2 equals r squared, where h and k is the center of the circle and r represents the radius. So let's take a look how I interpret what all of this means. So let's look at the circle. I'm going to take a circle and place its center here. And I'm going to draw the remainder of the circle here. So let's put some labels in here so we understand what we are talking about. This center can be represented by the numbers -2 and 3. So I'm going to place that here at the center of the circle. I also need to tell you what the radius of the circle is. The radius is the distance from the center to any point on the circle. All radii are congruent. I'm going to represent the radius by the number 5. Here. So if I wanted to represent the equation of this circle with an equation like we have here, I'm going to represent it in the following way. Let's get out my pen. Here. So, I begin with the x coordinates. It'd be x minus the number -2. Well, if you subtract the negatives, you get the positive. It's fantastic. Then I'm going to add on the the y coordinates into the circle. The y coordinate of the center is 3. So be subtracting 3. And this will all be equal to the radius, which is 5 squared. So 25. You can also do this process in reverse. If I gave you an equation like x squared plus y minus 3 squared is equal to 18. I can ask you what the radius in the center of the circle is. For the center, I need coordinates of the x value and the y value. Well, notice I'm not subtracting anything from x, so I represent nothing by the number 0. For y, I'm subtracting the number 3, so 3 will be the y coordinate. Here is the radius squared is equal to 18. This means if I take the square root of both sides, I get r as the square root of 18. Since there is a perfect square factor of 9, the square root of 9 is 3, so this will be 3 square root of 2. Yeah, it's fantastic. So that's how we use equation of a circle. I'm now going to hand this back to your teacher. Well, thank you, Arnold. That was fantastic. All right, let's move on with inequalities. We mentioned in class that linear inequalities have kind of a special process for solving them. I kind of solve it like an equation, and then we're going to have to consider what happens with those positive, negative values of the inequality. So let's take a look at this first linear inequality. I say linear, or an absolute value linear, because the value of the exponent of x is 1, which makes it a linear term. So looking at this value, if I solve this for the inequality, I will do that by subtracting 3 from both sides, and then I will divide by 2 to isolate the absolute value of x plus 7. Let me undo that, make a cleaner line. X plus 7 will be less than, and when I subtract 3, this will be 14, and when I divide by 2, 14 divided by 2 will give me 7. So, absolute values, recall that I can have either a positive or a negative solution. When the positive is would be x plus 7 is less than 7, and the negative would be negative x plus 7 is less than 7. Well, I'm going to kind of deal with this negative sign by multiplying both sides by a negative, so I end up with x plus 7 is greater than negative 7. Remember that when I multiply an inequality by a negative sign, it changes the direction of the inequality. So then I just have to solve these two values. For the first one, if I add 7 to both sides, I get x is less than 0. And when I subtract 7 from both sides on this one, I end up with x is greater than negative 14. So if I wanted to sum that up, all of my values of x have to be greater than negative 14, but less than 0. So there is the solutions to this linear inequality. Now, the process for higher power inequalities and fractional inequalities is slightly more complicated. So I'm going to write it out for you here. This is pretty much the procedure when I'm going to do inequalities of anything of a higher degree. So that's something not involving absolute values or linear values, but quadratic equations, higher power equations, stuff like that. So I first need to find what are called the critical values, which occur when the inequality is actually equal, or when the variables or the function value is undefined. Once I find those critical values, I'm going to plot the numbers, those critical numbers, on the number line, and then use test points in between those critical values to test each interval. So let's go through an example of how to actually do all of this. So first off, I'm going to find my critical values. So critical values occur when it's undefined. So I'm going to look to see if there's any situations where a value of x would make this expression undefined. There is none. We'll see an example of one at the next example, but there's no undefined values, so I don't have to worry about those in this question. And then I just have to worry about when it's equal. So rather than considering the inequality, I'm going to consider when 2x cubed minus 3x squared minus 32x is equal to negative 48. Well, to do that, I need to bring the 48 over and solve this equation. Minus 3x squared minus 32x minus 48 equals 0. Factor by grouping. This has a common factor of x squared in it. I'm left with 2x minus 3. This has a common factor of, it looks like, 16. This will be minus 16. And I'm left with 2x minus 3 equals 0. So I'm going to factor that 2x minus 3 out of each group. And I'm left with x squared minus 16 equals 0, which can still factor further. So this is 2x minus 3. This is a difference of two squares. So we'll factor 2x plus 4 times x minus 4. And the places where all those are equal using the zero product property is when 2x minus 3 equals 0, which means that 2x equals 3, or that x is 3 halves. This would be when x is negative 4, and this would be when x is positive 4. So I have three critical values that I'm going to need to plot on my number line. So I'm going to do that in a different color. I have the number negative 4. I have the number 3 halves, which is 1.5. And I have the number 4. So now I need to test these intervals, and I also need to consider whether or not those points are included. Now, since this was a less than or equal to inequality, the equals to part means that each of these lines, since they are solutions to the equation, will be included. So I'm going to do filled in circles to represent that those values are included on this interval. If it was not included, I leave these circles open. So now that I have these numbers plotted on my number line, I'm going to use test points to determine what's going on in each of these intervals. So a test point is basically a point which falls between the given numbers. A value to the left of negative 4, negative 5 would be one that I would use as a test point. Between negative 4 and 1.5, 0 is a very convenient one I can use as a test point. Between 1.5 and 4, 2 would be a good number, and then a number bigger than 4 would be 5. Okay, so now that I've chosen what my test points are, I have to test them by plugging them into this equation to see which one of them actually work. So to do that, I'm going to use a calculator. Okay, so now that I got a calculator, I'm going to test each of these test points. I'll start with negative 5. So what I'm going to do is type in negative 5 and store that as the value x. This is a time-saving tip so that I can now just type in the actual expression as I read it, which is 2x to the third power minus 3x squared minus 32x, and I'm going to type that in, and that's negative 165. So how I interpret this test value is negative 165 is what this entire expression is. It's negative 165 And since that is less than 48, this value works. So since that works, all of these points will be included in my interval. Okay, so let's pull that back up. Let me erase this. I'll pull my calculator back up, and I'll do another test point. So now this is why I did it store as x instead of just typing in -5, is that I can now type 0, the STO button, and the x key, hit enter, and I can do second entry, and pull up my second previous entry. If you're using a TI-84, you can actually hit the up arrows 2 times, highlight this, and enter again, and now it will recalculate it with my new value for x. So this entire expression, once I hit enter, turns out to be 0. And since 0 is not less than -48, the values where this test point 0 was taken will not be included. So I'm not including these values between here and here. My next test point is 2. So I'm going to test whether or not these values are included in my interval. So I'm going to again do 2, store as x, enter, pull up my entry, hit enter, and that's -60. Since -60, which is what this entire left-hand side evaluates to when x is 2, is less than -48, I will be including the values in this interval. So those values get included in my interval. The last one to check is 5. So I do 5, store as x, enter, pull up my entry again, 15. So my left-hand side is now 15, and since 15 is not less than 48, these values will not be included. So this test point failed. This test point failed, and I now know what my interval is. So my last step is to just write this interval up in my final interval notation. So all of the values that are solutions to this equation are everything from -infinity up to and including -4. So when I'm including a value, that's a closed bracket. Or it's all the values from and including 3/2 up to 4 and including 4. So this represents my interval. Okay, one last example for inequalities is if you have fractional inequalities, it's the exact same procedure. I need to determine my critical values, plot them, and do test points. So for this one, I do now need to consider my undefined values, because this will be undefined when x equals -5, because that will make this fraction undefined. And this will also be undefined when 2x plus 3 equals 0, or when x equals -3/2. Because when x is -3/2, this denominator will be 0, making this fraction undefined. So I've accounted for my undefined values. I just now need to account for when my values are equal. So do that just like I did before. Do that in a different color. I'm going to consider the equation. So when 4 over x plus 5 is equal to 1 over 2x plus 3, I'll do some cross multiplication here, and I get 8x plus 12 is equal to x plus 5. So that's 4 times 2x plus 3, distributing. Make sure you distribute that 4. And x plus 5 times 1 gives me this. Bring my x to one side, my numbers to the other, and I end up with 7x is equal to 5 minus 12, which would be -8. -7. Miscalculation. 12 minus 5 is -7. 7 divided by 7 will give me -1. So that is one critical value. My undefined values are my other critical values. So I've accounted for when they're equal and undefined, and I'm now going to plot each of those numbers, -5 being the smallest. So I'm going to leave an open circle because I don't know if it's included yet. -5, -3/2 is -1.5, which is smaller than -1. So -3/2 and -1. So those are my 3 critical values. Once I have them, I need some test points in between. So a number less than -5, I'll do -6. It's fine. You could do any number less than -5. Between these two, -2 works. And between these two, between -1.5 and -1, you could do -1.25. That would be one that would work. So those are my test points, and a value bigger than -1, 0 is a very convenient one to test. So I'm going to do the same thing here. I'm going to take my first value, -6, store it as x, and hit enter. The only thing that's slightly different in this example is that I have x's on both sides, so I have to compute both of these. So I'm going to hit 4 divided by, and then that entire denominator, so I need parentheses, x plus 5, so that my calculator knows that everything, the x plus the 5, is all in the denominator. I get one value, and I'm going to do 1 divided by 2x plus 3. And I got the other value. So notice that -4 is less than -0.111111. So since this is less than this, that value, this inequality is not true, so I will not be including these points, so that failed the test. I'm going to do the same thing with the -2. Store it as x. I can pull up my entries again. Entry, entry, entry. I get 1.3. This is actually much more convenient if you have a TI-84 because you can go up and just highlight each entry independently. And I have these two values. Now -1, which is what my left-hand side evaluates to, and 1.3 is what my right-hand side evaluates to. Since 1.3 is greater than -1, this interval passes this test point. So all of these values will be included in my interval. I'll repeat this process for -1.5, 1.25, store as x, enter, do my entries again. First one, second one. Okay, so for my left-hand side, I have 1.6 or 1.06. My right-hand side, I have 2. Since 2 is greater than 1.06, 1.06 being my left-hand side, 2 being the right-hand side. This fails my test, and then I just got to test the last point. So I'll plug in 0 for x. I mean, you don't even need a calculator for 0. If you plug in 0 here, you end up with 4/5 as the right-hand side. If you plug in 0 here, this term will cancel out. You end up with 1/3. 4/5, which is 80%, is clearly bigger than 1/3, which is roughly 33%. So this is passes my test point, and these values will be included. The last thing to check is whether or not these values are actually included. One thing to keep in mind is that whenever it's undefined, the undefined values never included in your interval. It's because it's undefined at that point, which means it could never be part of the solution. That value does not exist. So my undefined values were -5 and -3/2. So -5 and -3/2, those will remain open circles. They're not included in my interval. So my final answer will be from -5 to -3/2. And then I just need to consider the -1. Well, -1 is when these two values were exactly equal. And since this is strictly greater than, it does not include an equal sign underneath. This value will also not be included. So I'll say or -1 to infinity. And that's my final interval. For solutions for x. So these values x that make this inequality true have to be either between -5 and -3/2 or greater than -1.
I'll be back.